electric field lines or electric lines of forces. Now, before studying further, let me ask you a simple question. Have you ever saw the electric field around any charged body? Or if I talk of Michael Faraday, then I ask you a question that have you ever saw any effect which is created around the charged body? I told you that there is an effect present around the charged body, but I am asking you the question that is it possible to see that particular effect? Can you see some lines or circle vibrating away from the charged body? The answer is no. You will say no, we haven't seen it. And the thing that we cannot see it, we cannot believe it. So in that condition, I am going to tell you that there is a visual representation of the electric field. And this visual representation is called electric field lines. If you divide this word into two parts, that is electric field plus lines, then that means that these are the lines of the electric field, and the lines itself is a visual representation. In this condition, it visually represents the electric field. I am going to tell you that how the positive and the negative charges have their own electric field lines. If I ask you the first question, that what is the property of the electrical positive charge, then you say that that positive charge has a tendency to repel another positive charge. That means it contains whatever effect I am talking about, that is electric field, which is directed outward, that is away from the center of the plus Q charge. In this condition, you can see from this diagram that a positive charge is there at the center and the electric line of forces are drawn outward, that is away from the center of the charge. This is how the electric line of forces visually represent the electric field around any charged body. Now, second is the case when we take a negative charge. What is the property of a negative charge? The negative charge has a property to attract another positive charge. In this condition, we can say so by diagram that the negative charge has electric line of forces which are directed towards the center of the charge. Okay, that is the lines are drawn towards the center of the charge. So this is how the electric line of forces are represented. Now further, I am going to explain you that how these electric lines of forces play a very important role in electric field determination. The electrical lines of forces is a vector quantity that represents the magnitude and direction of the force exerted by the charge on the nearby objects. There is also a simple notation according to which the electric line of forces tells the magnitude of the electric field. In this condition, you can see that there are two circles, okay, capital A and capital B. Capital A has rare lines of forces which are drawn outside are rare, less dense. So less dense, the area around the electric lines of forces, if are less dense, it represents less electric field. If the lines of forces are highly dense, in case of B, then the strength of the electric field is high in this condition. So this is how the visual representation is accomplished. Now moving on to some complex situations. In this condition, we have taken two charges of same magnitude but opposite polarity. One is the charge with plus Q and the another is the charge with minus Q. You can see from the diagram that positive Q charge has their own field which is directed outward. The negative Q charge has their own field which is directed inward. So both the electric lines of forces mingle each other, that is they mutually interact with each other, and on interaction you can see that the lines of forces starts from the positive charge towards the negative charge, and the diagram represents that these lines of forces forms the closed curve around the positive and negative charges. So this is one of the most important property of electric lines of forces, that it always starts from positive and end towards the negative. Now let's take another situation. In this condition, we have taken two positive charges. Okay, now the two positive charges have the electric lines of forces directed outward, and when they are brought close together, then they put pressure or they repel each other, which can be shown by the electric lines of forces. Their electric lines of forces mutually interact with each other and put pressure on each other, and due to this the electric lines of forces do not form the closed curve, rather than that they pushes outward. So this is how the electric lines of forces in all conditions are easily represented. Let's come to the next important topic, that is the properties of electric field lines. The first important property is that the electric lines of forces form a closed curve. We have already discussed upon it that it starts from the positive and ends towards the negative end. That means it forms a closed curve. The second property of the electric field lines is that the field lines must be tangent to the direction of the field at any point. Now let's see what I mean by this statement. Now this is the diagram, the same diagram as we have seen till now. Okay, the positive charge and the negative charge and the electric lines of forces surrounding it. Now let's take a very small test positive charge near to the electric lines of forces. Okay, when we have taken this small positive charge near to the lines of forces, then if you have to find the electric lines of forces at that small charge, then it can be only found by drawing a tangent over the direction of the electric lines of forces, which is created by positive and negative charges. So this is how the electric lines of forces are represented. Now what is tangent? Tangent is a straight line which is drawn over the circumference of the circle. It passes from the circumference of the circle to the outside. So in that condition, the tangent in this diagram, in this what we have studied, you can see that the line touching the electric line, the curved portion of the electric lines of forces is represented as the tangent, and it shows the direction of the electric field of that small test positive charge. The third property is that the greater the line density, the greater will be the magnitude of the electric field. We have already shown you that if the electric lines of forces around any charged body is denser, then it represents higher value of the electric field. If it is rarer, then it represents the smaller value of the electric field. The fourth point is that no two electric field lines intersect each other. What do you mean by this statement and how can we prove it? In this condition, let me draw two lines. Okay, these two lines intersect each other at point P. Now you can see from these lines that at point P there are two directions, that two in the forward and the two direction at the back. Now, is it possible for electric lines of forces to have two directions, the forward or two directions the back? No, it is not possible. If it is not possible, then that means that the intersection of the two electric lines of forces is also not possible. So these are all about the properties of electric lines of force.